All right, is that gonna cooperate for me? Yeah, there we go. All right, here we go. So here on number 12, it says that two triangles can be formed. Solve for both of them. So I don't have to do any like, oh, cheapers, creepers. All right, so here we go. Have your attention, please. So this is Landon's question, number 12. So number 12 says, two triangles can be formed. Solve for both of them. So here I don't have to worry about the situation or figuring out what's going on because I'm told it's a two triangle situation. So I know it's an SSA situation because that's the only time you can get two triangles. So I'm just going to start by like making myself a little place to record my answers. I don't want to accidentally forget to find something. So I'm going to start by writing down the given information because that is part of both triangles. And then I'm going to need to find triangle angle A, angle C, and side C. I'm going to add a subscript on these angles A, angle C, and side C so that it's easy to differentiate when I'm dealing with the angle A and triangle 1 and triangle 2, etc. Everybody cool with the initial setup here? Okay. The other thing that I'm going to do is I'm going to make a space to do my work for triangle 1 and a space to do my work for triangle 2 so that I don't accidentally use the wrong information for the wrong triangle. In general, what I like to do is I like to solve all the triangle 1 stuff first and then find the triangle 2 stuff afterwards. You could jump back and forth and do it at the same time, but I think the odds of using the wrong information, the wrong triangle goes up if you try to do that. So I like to just do all of one triangle and then switch and do all of the next triangle. Okay, so I'm going to start by using a law of sines. Since I know both angle B and side B, I'm going to start by saying sine of B over B equals, and then the other piece I know is side C, so I'm going to be finding sine of C 1 over 25. I guess I could make that a little bit neater. So far, so good? Okay. I'm going to cross multiply, so I get 21 sine of C1 equals 25 times sine of 38. I'll divide by 21. And then to get rid of that sine in front of my angle C1, I'm going to use sine inverse. And now it's calculator time. When I'm going to type this stuff in my calculator, I need to be wary about my calculator mode. What mode should my calculator be in for this problem? Degrees. How do I know degrees? The angles are given to me in degrees. Very good. So I got 4713 for my angle C1. Oops. I don't know why I wrote C1 here. It's A1 that I'm solving for. I already have side C. Mr. Kulik, you dummy. Okay. Now that I have angle C1, getting angle A1 is going to be really easy because I have two of the three angles in my triangle now. So 9487. Everybody cool there? And now that I know angle A, I'm able to set up a new law of sines and solve for side A. So I'll do sine B over B equals sine of A1, well, angle A1 over side A1. And then again, we'll cross multiply. And then divide by sine 38. And I'll just type that into the old calculator. Old calculator. So that gives me 33.99. Go write that down real quick. And I'll pause here for those of you that are copying, since we've been going there pretty good for a minute. Okay, let's start triangle 2 then. So triangle 2 is actually less work than triangle 1. In triangle 1, we had to use the law of sines twice. In triangle 2, we only have to use the law of sines once. But what's really important in triangle 2 is that we're solving the same pieces in the same order that we did in triangle 1. So the first thing we found in triangle 1 was angle C1. So the first thing we need to find in triangle 2 is angle C2. Now this is really easy to find because there's a relationship between angle C1 and angle C2. They are supplementary. So I can just do 180 minus that angle C1. And there's my angle C2. So 132.87. Oops, over here. So far, so good. Now that I have this, getting angle A2 is really easy because I still have my angle B. And now I have this new angle C2. So that's 9.13. And now to find side A2, I'm just going to do the law of sines just like I did before. So I'm going to do sine b over b equals sine a2 over side a2. And then I'm going to cross multiply and divide. I'm going to skip a little bit of the algebra here because it's really the same steps as we did in the previous problem, just there's one number is different. So I feel like that's okay at this point, right? Hopefully at this point you've done a little bit of practice here and you're seeing that like, Mr. Kulik, this is like the same algebra over and over and over again. It's like the exact same steps like almost every time. And I'd be like, yeah, good. That is what you should be noticing. Algebraically, again, not too tough. It's the same solving techniques over and over and over again. So that's 541 we got there. So that's my problem. Now, other than being long, it's not too bad, right? I mean, just time consuming because there's a lot of things to find. But none of the individual solving steps are very complicated. Again, the biggest thing to remember is when you're dealing with the second triangle, you have to solve the pieces in the same order that you did on the first triangle. And to find that first angle, it's just a supplement of the first angle you found in the first triangle. That's the typical place students get stuck or make a mistake, is they go out of order or they forget that supplementary relationship. Who's next? Happy to do more. I know that felt like it took forever because I couldn't get my stuff working, but we got there. We just had to reset the computer enough times to where it decided it was going to behave. Jane.
Could you do 6?
Sure. So the directions on 6 ask us to determine whether there's 0, 1, or 2 triangles possible. So I'm going to start by drawing a picture and looking at the situation. So what scenario are we in? Is this side-side angle or side-angle-side? Side-side angle. Okay. In side-side angle, the first thing we need to do is we need to look at the size of the given angle. That's angle B. Is angle B acute, right, or obtuse? Great. It's acute because it's less than 90 degrees. Okay. So in the acute sense, either it's going to be one triangle or it's going to be that ambiguous situation where it could be 0, 1, or 2, and we have to do a little bit more. So what we need to check is we need to compare the size of the angle opposite, or the side opposite our given angle, with the other given side. So B is the side opposite our given angle, and the other given side is A. Is B smaller than A, equal to A, or bigger than A? Smaller. So that situation where the side opposite the acute angle is the smaller side, is that ambiguous 0, 1, or 2 triangles? So to check which situation we're in here, we do the longer side times sine of the given angle divided by the shorter side. And that number is going to tell us what is going on. So 13 times sine 87 divided by 4. So I get about 325 there. And there's 3 conditions based on this number. If this number is less than 1, we get 2 triangles. If that number is equal to 1, we get exactly 1 triangle. And if that number is bigger than 1, like we have here, there are 0 triangles possible. And for this problem, we're done because we're not asking to solve anything. We're just asking how many triangles do we get. Even if we're asked to solve, we'd be done here. If there's no triangle, there's nothing to solve for. But Jane, is that what you needed?
Yeah.
Sure. Victoria?
If it's like an obtuse triangle, like the
It could be 0. Yeah.
how do you do it?
Well, you just have to, so if this angle is obtuse or 90 degrees, could be right also, we just have to check to make sure the side opposite it is bigger, is the biggest of the 2 sides that are given. Because if that angle is a right or obtuse, that means it has to be the biggest angle in the triangle. Because you can't have a triangle with 2 right angles or 2 obtuse angles. There's only 180 degrees in your triangle, right? So if that obtuse angle is the biggest angle, the side opposite it must be the hypotenuse. It has to be the longest side we know. So all we need to check is to make sure that side opposite it is bigger than the other side that we're given. If it is, 1 triangle. If it's not, there's no triangle possible. Exactly. Yep. Landon?
Would it ever be possible that the opposite sides look the same as the other
Yeah.
side? Like, what do you do then?
Well, depends on what the angle was.
So, like, if it was like an obtuse,
Then you can't do it because the hypotenuse has to be the longest side. If the hypotenuse is the same length as another side, that can't be the longest. 0 triangles. Now, if it was an acute angle here, and they were both the same length, that's fine. It's just 1 triangle. So just to kind of summarize that situation, so if let's use a color that's easier to see. So if the given angle is greater than or equal to 90 degrees, so that means if it's obtuse or right, and the side opposite the given angle is the biggest, then you just get 1 triangle. Otherwise, 0 triangles. So if that side opposite is equal to the other one or smaller, 0 triangles. Then we say if the given angle is acute and the opposite, we should say the side, missed that there, opposite the given angle is the smallest, then that's the 0, 1, or 2 triangles. So you have to do that extra step. But otherwise, if that side is the same or bigger, you get 1 triangle. So obtuse and right, it's either 0 or 1. If it's acute, it's either 1 or that 0, 1, 2 situation that requires that extra step. And that's probably the easier way to kind of remember that. That just summarizes all those different cases into like 2 pretty easy to remember statements. They're a little bit less confusing to memorize than like, if AB is greater than BC like all that nonsense where like the labels are going to be different on the problem because you might have like PQR instead of ABC in your triangle. So it's like, okay, how do I resort this out with different letters? And this is much, I think, more practical. In general, anytime you're given a rule like that in a technical class, like a math class or science class or whatever, really the first order of business is like, okay, how can I summarize this in a way that's going to be practical for me to actually use it? Sometimes your rules or your theorems or your formulas or whatever are already really straightforward and easy to apply. Sometimes, like what we did before, there's like a lot of situations and it's like, how can I just summarize this into like something that's practical and compact like this, where it's like, I don't want to have to like sift through and like reinterpret all these angles or these names of everything to make sure I'm getting this right. I just want to be able to look at my picture and check and see what's going on. And this is really what a better formulation for that. You guys get what I mean? Yeah, of course. No problem. So I'll just put a little box around that so it's hopefully stands out. Victoria, that's what you kind of were looking for? Okay. Yeah, of course. We took kind of the roundabout way to answer that question. I mean, I answered it, I think, initially, but then we elaborated a little bit more because it felt like just a bunch of these questions were going to be coming. Let's just write a summary that's a little bit easier to access or a little bit more accessible. Who's next? Happy to do some more if there's more questions. Victoria? Sure. So 15 says solve if the triangle is possible. So here we're definitely going to need to make sure that we're checking what's going on, because it certainly sounds like from the directions that it would be possible that there is no triangle possible. So I'm going to start just by drawing and labeling a picture. Next thing I'm going to do is analyze what situation we're in. What situation is this? Side, side, side. Now, side, side, side was one of the situations where we can get zero triangles, right? It was this situation and side, side angle are the only ones that we can have zero triangles. Everything else, it's one, and it's obvious what to do. Those are the only two situations we need to be a little bit careful. Do you remember what the check is for the side, side, side situation? So we were going to use the law of cosines to do that, but before we dive into that, let's make sure this triangle is even possible. Yeah, so the sum of the two legs has to be greater than the hypotenuse. So how do I know which one's the hypotenuse, Mr. Kulik? It's the biggest one. It's the 20. So is 12 plus 15 bigger than 20? Yeah. So it's just one triangle. This problem is possible. If, say, it was C was 30, then there would be no triangles and you're done. But here we have one. So we are going to use the law of cosines. So since I have all three sides, feasibly, I have enough information to solve for any of the angles. However, to avoid any future SSA situations where I might have to have the 0, 1, or 2 triangles scenario, which is what I really want to avoid because that's a pain in the tuchus, which angle do I want to find first? A, B, or C? I want to find angle C first. Why angle C? Because angle C is going to be the biggest angle. Mr. Kulik, I don't know what the size of any of the angles. How the heck do you know angle C's got to be the biggest? Because side lengths are proportional to the angle measures. So since side C is the biggest side, I know angle C is going to be the biggest angle. So when I use the law of cosines now, solving for angle C, I'm going to have C squared is equal to A squared plus B squared minus 2 times A times B times cosine C. Okay. So to solve this, I'm going to subtract 12 squared from both sides and then subtract 15 squared from both sides. But I can't add 2 times 12 times 15 because that stuff is being multiplied to my variable. To get that stuff to the other side, I have to divide it. Everybody cool with the algebra to this point? And then we'll do the cosine inverse to both sides. Now, when I type this into my calculator, if you haven't been using the fraction command on your calculator, boy, how do you want to do it for this kind of a problem? Because there's about, I don't know, like 4 extra sets of parentheses you'd need to use here to get this thing to do it, the calculator to do it in the order you want. Or I can just use that fraction command and type it in exactly like it looks on my sheet of paper and not have to worry about it, which is what I would prefer to do because, you know, my life is hard enough. I don't want to have to fight with my calculator about making sure it's doing the order of operations the way I want it to. Oops. I guess the order doesn't really matter down there. Okay, when I do that, I get 94.94. Okay. Now that I have one of the angles, that means I have an angle and its opposite side. So I can use the law of sines next. But again, I could feasibly use the law of sines to solve for either angle A or angle B. Again, I have to be careful here because I don't want to accidentally run into one of these SSA situations where can I have 0, 1, or 2 triangles, because again, that gets real complicated real quick. Which triangle is the one that I actually want? I don't know. It becomes a mess. I want to avoid that because Lord knows my life's hard enough. To make sure that we avoid a possible SSA situation, which angle do I want to solve for next? Angle A or angle B? I want to find angle A next because it's going to be the smaller of the two. So the trick here to remember is if you have the choice between which 2 angles to solve for, or choice between some number of angles to solve for, if you're using the law of cosines, we find the bigger one first. If you're using the law of sines, you find the smaller one first. Everybody's cool? So we'll cross multiply. and then divide by 20. And then do the sine inverse. So there I get 3671. And then angle B is pretty easy to get because I have two of the three angles. I can solve for that third one. So that's 4835 there. Victoria, this was yours, right? Yeah. Does that feel okay? So again, the algebra steps, pretty easy, right? We're just plugging stuff into formulas and doing basic algebra things. The thing that you need to be wary about is on a problem like this where you have to choose which angle to solve for first, we have to be a little bit careful. If you're using the law of cosines to solve for the angle, you want to find the bigger angle first. If you're using the law of sines, you want to find the smaller angle first. Okay with that? Again, I want to make sure just that I say that a couple of times because that's the place where most commonplace mistakes get made is you find the wrong angle first and then you end up with the wrong answer because you stumbled into an SSA case, possibly, and then found the wrong. You just found the first triangle and really you wanted the information from the second triangle or something, and it's hard to know even in an essay, like in one of those 0, 1, or 2 triangles cases inside of one of these, like which triangle is going to be the one you want the information from. It's a big mess. We just want to try to avoid that by doing things in the order that we've described here. Because if you do that, then you don't have to worry about it, which is preferable than rather to have all of a sudden trying to solve for 2 separate triangles and figuring out which triangle is the one you want out of there. Ugh. Okay, anybody else? Landon.
Are we given any?
So I will give you like the formulas for law of sines and law of cosines, and then we'll see a couple more formulas in the last chapter. I'll give you the formulas with the letters, like sine of A over A equals sine of B over B equals sine of C over C. So you don't have to memorize the formulas, but you would have to know how to use them. Like, what order do I solve for things? Like, when do I use which one? That kind of stuff I would expect you to have memorized. Okay? Does that seem fair or fair enough? Okay. Cool. So, at this point, we finished the first 3 sections, sections 1, 2, and 3. This chapter has 4 sections in it, so there's a chapter 4, or section 4 as well. We're going to worry about section 4 next time. We'll do a homework quiz on these first 3 sections next time. And then the class after that will be the review, and the class after that will be the test. I'll probably get into My Notre Dame and put the dates in there for that stuff here later today. But we have 30 minutes or so left. If you look in the content library at OneNote, I have this extra page dated for today. And these are just some examples of kinds of questions I might put on a homework quiz. So I have the question and then the answers form. If you want to take a few minutes with a partner, you can kind of play around and plug through some of these and see if you can get the right answers. This isn't an assignment. It's just kind of an exercise for us to work on in class here, to fill up a little bit of time rather than like continuing to bulldoze ahead. So I would really like it if you were able to try to do a little bit of this today in class. And if you get stuck on something, you can come up and get some specific feedback, and I can help get you straightened out and talk about what's going on or what's wrong or what's not working and all of that. Okay? Sound fair to you guys? All right. So if you need to get up and move around or sit next to somebody you like to work with, or you can work by yourself, I'm cool with you kind of doing whatever works best for you. But I would really like you to try a little bit of these problems here in class, or work on things from the homework again. As long as you're doing something and checking it and practice, I'm happy. Okay?